Well, good evening. Welcome to Space Oddities. If you've just been watching us, sorry about that. We appeared to have a last-minute technical glitch, but I hope you can see us now. Anyway, not to worry. Thank you so much for being here this evening. Joined this evening by Daz and Michael and Roger. Lou is flying to... where's Lou going exactly? Does anybody remember? He's going to an astronomical event, isn't he?
Yeah, I think he's on his way back now. I think it was over the weekend. I think
he's on his way back. Okay. Well, Lou's unable to be with us this evening, but never mind. Hope everybody's well, and we've got a bit of a packed show for you tonight because 1 second.
Hey, Sandra.
Sandra.
Hey.
Hey,
Hello.
Sandra. How are you?
I thought I'd pop on.
By Sandra. How are you?
Okay, you all right?
Yeah, fine. You?
Yes, okay, thanks. It just
good.
On the hello.
Well, thanks for joining us.
Thank
Nice to see you. So, yes, I was saying this evening we're going to be talking a lot about what's been in the news over the last 24 hours, which if you missed it, is the first images from the Vera Rubin Observatory. And astronomers worldwide, I think, have been universally shocked at the sheer quality of these images and what it means for the future of astronomy. So we're going to be talking a bit about that. And also a bit later, we've got Constellation of the Week. I'm afraid I just got back off holiday last night, so I haven't had time to put the news together, nor the Einstein of the Week. So apologies for that. They will return next week, and we'll hold the stories over till then. Yes, so I had a lovely time in London, staying with some friends, seeing the sights, showing my daughter around London, which we haven't ever really done. So it was absolutely brilliant to be there, and we had glorious weather the whole time. So that was very rare for us to be in London during more or less a whole week with brilliant weather. It's absolutely superb. So there we are. All right then. Well, just before we start, I've got a question for you, viewers. Just let me get the chat up so I can see what's going on. 1 second. Hello, Paul. Hello, Kev. Hello, Ian. Gerard, nice to see you. Thank you so much for your donation, Gerard. As ever, very kind of you, sir. And hello, Derek. Yeah, everybody's there. Okay, so let me ask you this, viewers. How can we put this best? Okay, so as you know, on Space Oddities every week, we deliver a presentation to you about an extremely wide variety of subjects. The first question is, would you like to actually own those presentations so that we can enable you to download them after the live stream or at your leisure after the live stream? And secondly, would you be willing to pay a small amount every month to receive them? We are looking at ways of monetizing what we have and getting us on a more stable income footing. So what we were thinking is offering you all our presentations, including the notes and everything that go along with them, for a small monthly fee. If you would like something like that, then please tell us in the chat, because we would love to get your opinions. So do tell us, and tell us what you think. If you would like to have the Space Oddities presentations, and we can deliver it to you as a PowerPoint or Google Slides, I think are our two options, then tell us. Anybody got any thoughts about that? Let's have a look. Okay. Well, it doesn't appear to be much of a reaction there. So what we'll do first of all is I think we'll go straight over to Roger this evening for his look at the night sky and the viewers gallery. So over to you.
Oh, thank you very much. Okay, so we're heading towards the end of June now, as you do. So we'll be coming out to a new moon on Wednesday, which will be good. So things are looking quite reasonable. Of course, Wednesday, with me in the location where I am, it's going to be bedlam because Glastonbury Festival site will be opening up and there will be traffic chaos for miles around the area, so I'm staying put. But that's besides the point. So now we've got past the summer solstice, the days will be gradually getting to a point where we get astronomical darkness. So that's a bit of a yippee-yi-yay insight. But when it does get darkish, as we look towards the southern skies, we can start to see the summer triangle looking rather glorious. And well, we've got that there down towards the southern horizon. We've got the galactic core coming out through Scorpius and Sagittarius with all those Messier objects that we all know and love to get images of. And as it does get towards midnight, we've got Mars setting, so we're basically planetless during the night until we get to somewhere near dawn. And we've got Saturn, Venus, we've got Jupiter very, very, very close to the sun, so that's not really much of a sight to see. But we do have them there, and as I said, we've got the summer triangle of Deneb in Cygnus, Vega and Lyra, and Altair down there to make up the summer triangle, which I'm sure most of you already know all about, being people that you are. So we've got some good constellations. Now we've got Scorpius down in the bottom there with a Fucus as well. So we've got some really good constellations to look at, and also a lot of the well-known Milky Way going through Cygnus through the night sky. So all well and good there. But as we've got in the morning, we've got Saturn having a little glancing in the sky, sharing with Neptune. But unfortunately, with the brightness of the sky, I doubt whether anyone will be able to see Neptune very well. But there is a possibility of perhaps glancing at it before the sky does get any brighter before the sun rises. So we've got we've also got Jupiter and Mercury in the evening twilight just before sunset, so that should be quite interesting, but I would think it'd be quite a bit of a challenge really for anyone to try and do that.
Fantastic.
But we've got the Lagoon Nebula, which we will see more about later on. This image is one of mine that I took a year or two back, so this is all I can manage with my little telescope, as opposed to the Vera Rubin, which is somewhat more spectacular to say the least. But we do have some other star clusters which we've got in the Fucus and stuff, but I think I've really covered those in my constellation of the week. So there we go. So we've got in Hercules, we've also got a lot of interesting globular clusters, two of which are M13, which everybody knows.
Yeah.
But we also have M92, which is a bit of a four sibling, as you can see from the two images here, that we can see how similar they are, but obviously the size and brightness of the two are quite different. But it's worth having a look. So anything you want to have a look at, we can use with binoculars, and obviously the early morning with there is some darkness, and obviously do appreciate any dark skies that we can get to see any of these objects. So we do have an interesting gallery this week with the usual suspects, and the first one we've got is Michael Murphy's solar image that he took on the 18th of June, and this is one of his images.
That's nice.
Some very nice images there, Mike. And we've got some from Daz when he was away on his holiday in Lanzarote.
Oh, that's posh.
Mm. Yes,
They're all taken with a phone.
all done with a phone.
Lovely. Lovely, Daz.
It makes the cloud almost like noctilucent clouds.
Yeah.
Yeah.
I think also they're a little bit fuzzy because that was about a 3-second exposure handheld. So
Still
yeah.
very good. Well done, Daz. And then we've got boats on a moonbeam. Sounds quite romantic.
Oh. Oh, you're romantic, you.
So that was just the camera moved round slightly, was it? From that location?
That was that basically I did that as a portrait so that you're looking straight, because that moonbeam was coming straight into our apartment. That's actually from the balcony where we were actually staying.
Beautiful.
So
Lovely.
Yeah, got a more clearer sky there.
yeah, that was the first night.
And then we've got a sea star picture from Daz called Photo Bomber.
Yeah,
Oh.
this was I was going through my old images from the sea star, and how I missed this I don't know, but you can see there's a little meteorite in there. Or meteor, let's put it that way. Sorry.
A meteor, yeah.
Okay, so you got 2 streaks on that image.
Yeah, you know what the other one is, satellite.
Yeah.
Yeah. That's definitely a meteor, isn't it? Man, I'm mistaken that.
Yeah, I totally missed that when I went when I was going through them before.
Excellent.
Well done. Right, so we've got one from Lou of the Great Hercules Custer M13 with his C11. So we've got a quite a closer view with this.
Wow. That's dramatic, isn't it?
Certainly is.
Really
Yeah.
Well done, Lou.
Good old Lou. Makes a
Nice
change from the
colours for
sea star
those
picture
stars.
that he does.
Yeah.
Hey. Okay, so we've got one from Kenneth here, as usual, done from a scope in Hawaii, and this is ARP 286. So it's a yellowish barred spiral, and then we've got a few other objects there in the field of view, but it'll be quite an interesting object. Look at that.
Oh, wow.
Oh, that's
Amazing.
so wistful, isn't it? So lovely. And you can see the dust lanes as well. So
You can see the interaction between the 3.
Yeah, you can see how
You can see it
much
from
the
in, yeah.
arm's been pulled up towards the other galaxy there.
yeah, you can see a connection forming.
But, and then I did some solar imaging on the 18th. So, we got some yeah. The one on the left was a 16-panel mosaic. So that was quite fun. I thought, as there was interesting activity over the whole thing, I thought I'd try and get the whole thing. So that's the reason I did that.
That's lovely.
That certainly is.
Colour's amazing, Rod.
Yeah, thank you. And then Kenneth did a late entry, and this is the central pole of the Cat's Paw Nebula from the same telescope in Hawaii. And we've got...
Oh, that's nice.
Oh, Cat's Paw Nebula.
Yeah.
Wow.
Yeah, the center pole of that object.
Yeah, I was just going to say, it's quite deep, isn't it?
That's amazing.
And that concludes the gallery.
Right, thank you very much, Roger.
Roger.
Don't forget, if you would like to send your images into the gallery each week, you can email them to gallery@spaceoddities.space, one image per email, please, and they will also be featured in your own little gallery on the Space Oddities website. So, just before we go on, Sandra, what have you been up to? Been doing much observing?
Well, a little bit, but only with the sea star.
Right.
Yeah, but not a lot really at the moment. But once tonight, lights go dark, I will. Yeah.
Yeah. Yeah. So are you getting used to the sea star now? Is it producing good results?
Yeah, it's not bad. I do need to use it a bit more though. I should be
Sure.
up there more really trying to use it. But I think, like I said, once the nights get darker earlier, and
Yes.
the winter
Absolutely.
constellations and things, then I'll probably be outside a lot more.
Well, that's happening soon. Patience, as of it. Okay. So, yes, so the Vera Rubin Observatory has released its first images, which were actually taken last October as part of its testing. So these are test images, but as test images, they have stunned the world with a number of things: their sheer size, the quality of the images, the actual precision of them, and this is going to open a new era of astronomy. The real work of the Vera Rubin telescope starts in October, when it starts a 10-year survey of the southern hemisphere sky. And what it's going to do is to photograph each area of the sky every 3 nights, and do it again for 10 years. So every 3 nights, it'll build a complete map of the southern hemisphere sky. So let's first of all go over to a timeline of the whole project, because I think to know where we are and where we're going, we need to know where we've come from, as ever. So just give me a second, and let's just have a look at the timeline of the Vera Rubin telescope. See that? Let me just okay. Oh, it didn't work? No?
No.
Okay, let's try again.
Technology is wonderful.
Is it there now?
Yeah.
Okay. Right, if you could just maximize that, Daz. So the Vera Rubin telescope was first considered way back in the mid-1990s. And astronomers wanted to build a telescope to study the nature of both dark matter and, as it later was discovered, dark energy. But it was primarily going to be a dark matter telescope. The idea behind the telescope was that if you could study the history of the universe and how things have changed, then you can understand a lot more about the history of dark matter. To do this, you would need to observe a large portions of the night sky at the same time, hence the need for a wide-angle survey telescope. So the basic design of the telescope began in 2001, and the science objectives were formalized. There's an image on the right there of the main mirror being ground. So it took a long time to get those things together, but in 2007 they were able to obtain the money for building the main mirror, the 8.4 meter mirror. And in 2010, the American Decadal Survey of Astronomy, which is a study that comes out every 10 years to basically say what are the priorities in astronomy, what should we be building, recommended that it was definitely a good thing to be built, that work on it should definitely go ahead. And as it says, it was the highest ranked ground-based project in the Decadal Survey in 2010. So this essentially gave a green light to the telescope moving forward. Between 2014 and 2020, the funding was obtained from the NSF, the American National Science Foundation. That was approved in August 2014. In 2015 was the groundbreaking, the first stone in Chile on the 14th of April 2015. And in those days, the observatory was called the LSST, which stands for Large Synoptic Survey Telescope. And in 2020, it was renamed after the astronomer Vera C. Rubin, Now, just a little bit about Vera Rubin herself. She was an American astronomer whose pioneering work provided the strongest evidence for the existence of dark matter. That's what she's mainly known for, doing the groundwork to identify, well, not identify, but to tell the world that there was something missing with our understanding of the universe, and it was dark matter. She's faced significant gender barriers in her profession, but she was elected to the National Academy of Sciences and she got many honors. Many people thought she should have received a Nobel Prize for her work on dark matter, but she never did, unfortunately. But at least now she has an observatory named after her, although she never lived to see it because she died in 2016. From 2015 to 2023 was the construction of the world's biggest ever digital camera. You can see it there. This is the size of a small car, but it's about 10 times heavier. It's a 3.2 gigapixel CCD, massive resolution. And during this period, they also built the 8.4 meter mirror. Unfortunately, the whole project, as so many others were delayed by COVID, but by 2023 the camera had been finished, and 2023 to 2024 the camera was installed into the telescope. There was final assembly, and the first images were captured on the 24th of October 2024, and these were the images that were released yesterday. Now there will be several months yet of testing before the actual survey of the Southern Hemisphere night sky begins. It is a global milestone for astronomy. The survey itself should begin in October of this year, and we can't wait to see the results. So full operations begin in October 2025. At that point, public access to the data will be granted to scientists and citizens. The Vera Rubin data is open to all. And there's going to be about 20 terabytes of it per night. So we're expecting this deluge, as it says, of data. Over the 10-year survey, it's going to be 500 petabytes of data. And it will involve, as I said, the complete imaging of the visible southern sky. Now, the advantage of having a survey telescope like this is that the telescope will be able to spot very quickly things that change in the night sky. It's going to take a new image every 40 seconds. And then after another 3 nights, it's going to take the same image, an image of the same area of sky again. It will be able to see things that have changed. And it's going to send out an email alert for anything that has changed in the night sky. And I was reading yesterday that possibly 50 million alerts per night will be sent out. Not that I don't think anybody wants an email with 50 million emails in their inbox in the morning, but you'll be able to filter them by the type of object that you're interested in. So this will be satellites, this will be supernovae, this will be basically anything that changes in the night sky. And this is the sheer power of the Vera Rubin telescope, being able to see change in the night sky to help us understand the universe more through what's called time domain astronomy, watching things change over time. So the expected discoveries of the Vera Rubin. The Vera Rubin telescope, the LSST, now don't forget, LSST used to stand for Large Synoptic Survey Telescope before it was renamed as the Vera Rubin Observatory. Now they've used the same letters, and LSST now stands for the name of the survey of the Southern Hemisphere sky that the telescope is going to be performing, and that is the Legacy Survey of Space and Time, LSST. So during the LSST, the telescope is expected to detect 5 million new asteroids in the solar system, 300,000 supernovae, 20,000 dwarf galaxies, 2,500,000 new quasars that we didn't know about. That's particularly exciting. And transnet tuning objects, or TNOs, is expected to discover another 5,000 simply by seeing that something in the night sky has changed. And that is a hell of a rate of discovery, that we're going to discover some amazing things out there. Asteroids, of course, we're interested in, just in case any of them are on a collision course with the Earth. But let's have a look at the asteroids in a bit more detail, because even during its test images, the Vera Rubin Observatory managed to detect a couple of thousand of new asteroids. And have a look at this short video, which will explain everything. So on night 1, it discovered 989, night 2, 1355, 1358, 1638, 1793, 1796, 2,104 asteroids over the 7 nights. And that is just a tiny slice of the sky that it's observing. If you look at the asteroid belt around the sun, the Webb is only looking at that portion of sky, because it's only a tiny part of what the Vera Rubin telescope will eventually do. So there we are. So that is the potential for discovering new asteroids. It discovered a few thousand new asteroids in just a few nights, and this is truly a big step forward for hunting down potentially rogue asteroids that could threaten us. Now, in terms of resources, there are going to be lots of resources available if you do want to get involved with all of this data, because, as I said, all the data will be public. You can do so because the Zooniverse is in partnership with the Vera Rubin Observatory, and there will be some projects on Zooniverse to analyze, so that you can sit and analyze the Vera Rubin data. They're not there yet, of course, because the survey hasn't started, but when it does, there will almost certainly be at least several projects where you can in some way help to analyze and interpret the Webb data. I'm really looking forward to seeing those projects on the Zooniverse. So the resources here, the web address for the main web page for the Vera Rubin Observatory is https://rubintelescope.org, and the viewer to view the images is https://skyviewer.app/explorer, and the Zooniverse is www.zooniverse.org. Now, when it comes to the viewer, I'm going to show you how that works now. So just give me 1 second, and we will set this up. Okay. Okay, hope you can see this. So this is one of the test images of a cluster of galaxies in the Virgo cluster. And you can drag this thing around, but you are only seeing a small fraction of the total field of view of the telescope. In fact, this image, if you wanted to display this image at its full size and full resolution, you would need 400 4K televisions to display this image. That's how massive this image is, and the resolution that it has is absolutely amazing. You can also, either with your mouse wheel or using the plus and minus signs there, you can zoom right into this data as well. Look, I've just found a very, very distant spiral galaxy there. We can zoom in even further before it gets too pixelated to cope with. That's about as good as we're going to get. But that is 1/10,000th the field of view of the Rubin telescope. And if I zoom right out, you can see the whole image here. But as I said, it would take 400 4K televisions to show you the complete size of that image at its full resolution, which is absolutely amazing. So this is why there's going to be that data deluge during the 10 years of the survey. So there we are. Okay. So that's a bit of a look at the timeline of the Vera Rubin telescope. Oh, have we lost Sandra?
Yeah, it was Sandra's computer that was causing the echo.
Oh, was it?
So I'll turn the sound off on her side.
Oh, okay.
She's going to join us on the chat on the YouTube instead.
Oh, okay.
Yeah.
Oh, that's a shame. That's a shame. Right, so that's the background to the images that were released yesterday. And Roger, you've got a presentation here about it you'd like to... Derek, no, you can't. You can't get a full-size printout. No, I'm sorry.
It'll be too big for your wall, I think.
Yeah. Okay. So, Roger, take it away.
Right. So, continuation of what my colleague Andy has presented to you, and we've got some more information here. It's 1,600 meters above the plains of Cerro Pachón in Chile. So that's the reason why we've got it. I do believe that, I don't know if this is true, but I think due to the darkness of the night skies, I don't know if anyone's allowed to drive up with their headlights on in the dark up to the observatory for fear of interfering with the sensitivity of the camera.
I was reading about it. They're not. It's strictly forbidden.
That'd make it interesting, wouldn't it?
Yeah.
Yeah, absolutely. So
what hairpin?
So it says each image covers an area of 45 full moons. So and then they stitch it all together to make that image that Andy showed. Some more interesting, as it says, 400 Ultra HD TVs for to be able to see it. So it gives you a good idea of how huge it is. So it's a 3.5 degree field of view with that camera. So good idea to see what software they use to stitch them all together. So it will be scanning the entire sky as it's every 3 nights. So it will be a matter of carefully enjoying what it sees. So one of the images was the Virgo cluster, and there's about 10 million galaxies in this one image that it's managed to see. Here's the image which we have seen, and if I go on to the next slide, we've got the annotated items of the different objects that it has actually managed to capture on this. It has managed to capture M49, and then we've got a few other images there, but it was quite interesting.
Are we saying then that the images that are not annotated, the objects that are not annotated, are new objects that haven't been seen before?
Very probably.
Yeah.
Yeah.
Who's volunteering to put a number on each one of them?
I don't know. So there might be a new catalogue system that Vera Rubin will perhaps start up and get each and every object numbered and lettered. So that'll be an interesting.
Yeah, sorry, Roger, I didn't mean to talk over.
That'll be an interesting pocket version of all these objects to go and look for.
Yeah, do a Vera Rubin marathon in one night. What amazes me is the colours in these of some of these items. I mean, they're so red, blue, and it's amazing.
And this is an actual. Are these actual colours? They're not like.
No,
they are.
These are actual colours.
Yeah, not like the James Webb where it's like, because it's infrared. These are optical.
Colors, yes.
Yeah.
You don't have to get the crayons out for this one.
No.
No, it's amazing, isn't it? So, but then we also had the Triffidan Lagoon Nebula as well, and this was quite good. I did try to download the original size image, and it was 24.5 gigabytes. So you could really zoom in to study the images, but I don't think I could manage that very well. I think it was a bit overloaded on the server, so I wasn't able to do that. But here's a closer view of the Trifid. As you can see, it's absolutely amazing. And seeing those little dark areas of gas there, hiding some of the stars behind that, which James Webb will probably be able to see through with its infrared. But,
yeah, that's true. Absolutely... Because you imagine a composite between James Webb and this. It'd be wonderful.
Absolutely. But looking at it, you keep zooming in, and you just keep seeing more and more stars in there. It's phenomenal, you know. Billions of stars in these images. So we've got some interesting closer images. I've not heard of Bochum before, so is that another new catalogue system?
What's that?
Bochum 14.
Bochum, I don't know.
So yeah. Anyway.
Yes.
So
what do you think? What do you think if Carl Sagan saw this?
Oh God.
So we've also all these images that we're going to have to study for decades, even from just that test image, would be quite phenomenal, I would have thought.
Well, Derek says we need another one for the Northern Hemisphere.
Yeah.
Yeah.
The problem with that, Derek, is there actually anywhere dark enough?
Yeah.
In the Northern Hemisphere.
Yeah.
That's the problem. They've chosen Chile because it's got the darkest, clearest, most dusty skies in the world.
And driest.
Yeah, and driest. Yeah. But they might have trouble finding a similar site in the Northern Hemisphere. So, but you're right.
Yeah.
One of the Northern Hemisphere would be brilliant, but I don't think there would be a site comparable in the Northern Hemisphere where we'd be able to get the same sort of results.
So Rubin will collect more data than all previous optical telescopes combined. So
wow,
this gives you an idea of how phenomenal this data collection is going to be. And let's hope there aren't any hard drive failures.
And that of course is until the ELT comes online, which will produce even more data than the Vera Rubin.
I don't know. So it's going to be quite an interesting take of what is going to be actually discovered. What will be the next big announcement from the discovery of what they haven't been aware of yet, or what might be theoretically possible, but Vera Rubin might actually discover.
Indeed.
Who knows? So,
I think Andy's list will have to be revised very soon of things they're going to discover.
I'm sure.
So hopefully at some point we will be able to get some more interesting surveys done. So I do have some other videos that were available. If I can.
Can I just mention as well, for those interested, there's the camera, which is 3,200 megapixels.
Yeah.
Yes.
2,000 megapixels, something like that. Just by comparison, the average consumer camera on the market today for digital photography is something like 24 to 30 megapixels.
Yeah.
It can go up to 40 megapixels, but that's absolutely nothing compared with this.
No, it isn't. It isn't. And the fact that they've been able to build the world's biggest digital camera with commensurately the biggest CCD sensor ever built for a digital camera, is amazing. Absolutely amazing technology. But yesterday they proved that it works.
Yeah.
And just to answer Roger's question, The term Bocan classification of stars refers to the classification of stars within the Bocan star clusters, particularly Bocan 7, 10, and 11, which are known for their OB-type stars. These classifications primarily use the Morgan-Keynes system, which categorizes stars based on their temperature, luminosity, and spectral characteristics. So that's what this Bocan
Right.
classification is. So basically, it's using, well, the Hertzsprung-Russell
Oh, right.
technique. Hertzsprung-Russell technique.
Right. Okay. So if I can share this screen with the people on one of the objects. So this is showing you some variable stars that it's picking up.
No,
it's not.
it's not. We've got your sort of like your dashboard.
We've got your list of videos, Roger.
Oh, right. Oh, that's weird.
There we are. That's it.
Right.
Play that.
Okay.
I think you need to go back to the beginning, Roger. Right. There we are.
Now, some of these variable stars were measured only after like 30 seconds.
Yeah.
It's that
Wow.
sensitive.
You can see how much what time they were
243
taking.
and 315, so
30 minutes.
30
That's
minutes or so, yeah.
It's gonna find millions of these, isn't it?
Yeah, and this one's only after 12 minutes.
Yeah. Absolutely stunning stuff.
Yeah.
Amazing.
Brilliant.
Right. Okay, so that was quite interesting. So it just gives you an idea of just how phenomenally sensitive that camera is. In just half an hour, it just shows you a variation of that much already. So, right, okay, so if we show you another one, and this one will be, hang on, where are we? Right. Let me go back to the start. Right. Hang on. Right. So there. And no, it's not working.
Yeah. Hang on 1 second, Roger. Hang on. Try that. That is an amazing image, isn't it?
Yeah.
The colours are just unbelievable.
Yeah, it's brilliant, that is.
And don't forget, viewers, these are test images that were taken last October just to test the telescope. And, you know, the telescope obviously will be adjusted and tweaked to get the best out of the
sound out.
data.
That's better. You can hear us talking a bit more, but it gives you an idea of how phenomenally detailed these are.
Yeah. Fantastic.
Right. I have one more. That is the Virgo cluster.
Great.
So one more. Oh, hang on.
I love this one. This is just
Yeah.
This
beautiful.
just gives you an
Yeah.
idea of how you just go and pick an area and just keep zooming in.
Yeah. And that sort of S-shaped barred spiral there to the left,
Yeah.
elliptical.
Yeah.
It's beautiful.
Look at that line of
Yeah, all that
galaxies
interaction
and
and
stuff, yeah.
dust there.
Yeah, and just at the top, it's disappeared now. There was about 3 or 4 galaxies all interacting.
Yeah,
Mm,
incredible.
it's
And
amazing.
you will be able to get your hands on all this data, viewers, because it's all in the public domain. And using the Sky Viewer, as I showed you earlier, you'll be able to just sit for hours and just look through those images. Absolutely, absolutely unbelievable. Right, just before we go any further, do you want to stop sharing your screen, Roger? Or I can turn it off here if you like.
Yep, go on then.
Just one question there. I know you've answered it in the chat, Andy. Paul was asking, when do you think the ELT was going to have its first light?
Yeah,
Well, I know you've already answered it. It's March 2029 it's scheduled for.
that's
But
right.
I'll just give you a little bit of a warning there. Due to the budget restraints, some of these big telescopes are being shelved.
Yeah.
So just keep an eye on the news and see what actually happens.
Yeah, but that won't affect the ELT because it's European.
Oh, well, that's good then.
Yeah, so that's not
I
a problem.
forgot that. Yeah, I forgot that. Sorry.
It's only the American projects that are under threat at the moment. Well, it's not just the American projects because it's all international. So the National Science Foundation supplies the money for not just national but international astronomy projects. But the ELT is funded just from us European taxpayers.
Yeah.
So great. I asked you earlier what you thought about receiving SpaceOddities presentations, and thank you very much for your comments. I'm just going to go through some of them, if you don't mind. So can't see them now. Great. Okay. So Ian McIntyre suggests £5 a month. Derek says, I would love to pay a subscription, but I do not do online banking. Well, it wouldn't be through online banking, Derek. It would be on a card, almost certainly. So
send some lads round, Derek.
Yeah, or PayPal. If you want to give us your bank account details and your PIN number, that would be fine. So no problem at all. So we'd be happy with that. So let's get back to where it was. Gerard says, I have no problem in making a regular contribution if it means helping to pay the bills to keep us up and running. So be it. Well, thank you very much, Gerard. That's very kind of you. Thank you very much. Stuart says, would an annual payment be possible or would a monthly payment be preferred? Haven't worked it out yet, Stuart, but I'm sure we could arrange both. I don't see that being a problem.
We can make a 10-year payment. That'd be nice.
Yeah. You can make a 50-year payment.
A decadal payment.
Yeah, that's right. So there we are. So that's the comments I think we got so far. If any others of you would like to make a comment about whether you would like to receive the SpaceOddities presentations and whether you would mind paying a small monthly or indeed annual fee for it, then let us know, because we really need your feedback on this. Because
don't forget to look down the back of the sofa.
Yeah, that's right.
For all those odd pennies.
We are trying to get our finances on a bit of a more predictable setting, if you like, rather than it being a bit haphazard. So that would be great for us for that. Okay, let's move on. So that, I think, just about covers the Vera Rubin telescope. We've also had another item in the news this week, which was unfortunately the explosion at the Massey test site at SpaceX's Star City. Daz, do you want to talk about a bit about that?
Yeah, it's just, I mean, we haven't prepared a presentation for this, unfortunately, but I think it needs to be talked about the explosion of the Starship. They were priming themselves for a static engine test. They were filling it full with fuel. Luckily, there wasn't that much methane on board. And then what happened was they were just testing the flaps, which they always do, to make sure they wiggle and everything's free as part of the procedure. And then all of a sudden, for some completely unknown, well, it was unknown at the time, the whole thing literally disintegrated. It blew up. The actual explosion started at the top, and then it kept, of course, as it proceeded down, it then ignited the methane, causing an even bigger explosion. And when they've looked at the slow motion, um, the slow motion of the actual incident, if you watch it, it actually, the whole top section seemed to split wide open, and it seemed to start splitting from where the actual cargo bay is. And all it's just, it seems to unzip literally like a zip, and all this fuel and everything else and gas starts to come out, and then of course then it just ignites. And then of course that causes a minor explosion, which then, as I said, went on and caused a bigger explosion when it reached the methane. Now it threw debris all over the place. We've seen it all before when they've tried to land these starships, how far the debris can go. But the main problem with this, and it was put down to a composite overpressurized gas cylinder thing, and it's basically a big sort of like oxygen tank thing, and there's quite a few of them actually in the Starship itself. And what they do is they store nitrogen, and these pressurize the tanks and the engines, so that there's always pressure in them to force the fuel into the engines. And it seems that one of these failed. Well, what they did is they said it delaminated, because it's a composite. It's all these different layers put together. It started to delaminate, and fuel, they reckon, actually was able to somehow get in between these layers in the gas as well. And this eventually it built up, and then it just completely split. And this thing exploding actually split the top of the Starship in literally unzipped it, and it all fell apart. Now they had a similar well, they had exactly the same sort of problem with the Falcon 9 when they were first developing. With the no, it was the they were taking supplies up to the International Space Station. They were fueling it, this Falcon 9, and the same thing happened. And again, that was put down to one of these composite pressurized tank things. The only thing is that people are saying, "Oh yeah, but there must be a problem with them." But they are the same, but they're different. They're made of different materials, or there's something different about them. So yes, it is the same, but it's not. If you know what I mean, they're not exactly the same thing.
And this,
of course, sorry.
This COPV apparently failed at well below its maximum stress. So it looks like it was either a dodgy manufacture of the COPV, or something else happened that we don't know about. But the fact that these are mission critical components. It keeps that nitrogen gas pressurized at lots of atmospheres, and obviously anything under extreme pressure is susceptible to blowing up. But the fact that this one did, I don't know if they test the COPVs before they mount them on the Starship after receiving them from the manufacturer. I would expect
they will be now.
Yeah, I'm sure they will be now.
Yeah.
So
but they are tested during manufacturing, but
yeah, exactly. But
why this one passed, I don't know. But
no, I don't know. But the thing is that because they're such mission critical components, they need to be ultra careful in testing them. And as you were saying, one guy who used to be a SpaceX engineer was saying that the the problems are occurring because they're cutting corners at SpaceX because they're trying to save money, as ever. So they are cutting corners with the engineering. I don't know how true that is. I don't know if it's just a case of sour grapes.
Yeah,
but
could that be sour grapes, or is there actually a problem with?
But then you see, that would seem to be self-defeating, because if you are cutting corners to meet these time-defined objectives, because don't forget, SpaceX are still contracted to land people on the moon with Artemis 3, and they're up against it in terms of time. So it would seem to be self-defeating to cut corners on the engineering and just perhaps praying everything will be all right. I don't know. I can't see SpaceX being that unprofessional, to be honest.
Yeah, I mean, because it's a test, there will be no FAA investigation.
No.
You'll probably find the environmentalists will kick off again. But when they, but the main problem, and this is what even worse than actually losing the Starship, because this was supposed to be used on the next flight, test flight 10, isn't it? 10 is
Yes, 10, yes.
Yeah. But the damage that it caused to the MAS's test ramp or stand was absolutely massive, and a lot of the infrastructure around the fuel tanks, the oxygen tanks, and everything else of the pipe work that goes to feed all of this, a lot of it was seriously damaged, and I think the stand itself was damaged to a certain extent, and this is going to put them back. Knowing Elon and SpaceX, it's probably, I mean, what would probably take some people probably 8 or 9 months, it's going to probably take 2 months for him to repair that.
Yeah, I think the latest estimate was 2 to 3 months for repairing it.
Yeah, I think the next Starship has already been tested, but they can't do any testing of the engines until that is actually resolved. So nothing can happen until that's rebuilt, everything's tested again. Because this is one of those things where it's not just going to buff out. There's a lot of clearing up to be done. There's a lot of infrastructure that's got to be rebuilt. And as Andy says, they're under pressure for the moon landings, and this is just going to put a delay on everything.
Yeah.
But also,
Paul Wheaton says current thinking seems to be that the COPVs have been mishandled, causing microfractures.
Yeah.
Right. Nothing would surprise me, to be honest.
Yeah.
But
but like I say, everything now is pushed back. But the thing is, if you think this is now the 4th Starship that's been lost in a row, all right, 3 of them were in flight, but this is actually one that was actually on the ground. They're not even taken off now, and there's been a thing. Ian says, "Will Trump cut funding anyway?" Well, you don't know with him, do you?
Well, it can't. It's not publicly funded. It's funded by SpaceX.
Oh, yeah, true. But I think what probably Ian's referring to, with funding. But will
are you talking about the moon landings?
Yeah, the moon landings.
That's another topic.
Take that away. Let's see. That's another thing as well. I mean, is it from what we understand? Will there be any moon landings? Because the SLS and the Orion capsule are under threat of being cancelled.
Well, they're only under threat from Artemis 3. Up to Artemis 3, they're secure.
Yeah, because it's up to financial year 2026, isn't it?
So
it's just this is going to put a setback on the things. So basically, just another hold up and another delay.
Well, if you think that Artemis 3 is scheduled for 2027, by now the Starship should have been doing regular flights into orbit, and they should be about to start testing in orbit refueling.
Exactly, that's where they should be.
Yeah, that's where they should be. But because of all these setbacks, they are probably the best part of a year behind schedule now. So anyway, we'll have to wait and see. But it's a sad loss. But luckily nobody was hurt, because obviously they weren't, because the whole area was cleared because there was a static fire going on. So nobody was hurt. Thank you so much, Sandra. Thank you very much. #1 fan. Well, thank you. That's lovely. That's very sweet. Thank you so much, Sandra. Yeah, so we will wait and see. But you know, what can you say? It's another setback for Starship, which is proving to be a lot tougher of a nut to crack than I think even Elon Musk realized. But as we always say, space is hard.
Space is hard, and of course there was another explosion in the sky the last few days, and that's the supernova, the nova in Lupus.
In Lupus, yes,
Yeah,
indeed.
which
I think Michael's
is,
going to talk to us about that. Yeah,
Yeah, I've got a little bit about that in a bit.
it's a
Okay.
lead up. It's a lead up, Michael.
Yeah. Well,
Yeah.
actually,
I'm warming them up for you.
so I think we're ready to do Constellation of the Week now, are we not?
Oh, you think so?
Yeah. Okay. Let's go for it. So,
Okay.
Constellation of the Week.
Yeah, this is Constellation of the Week. This time it's Corona Borealis, a small constellation when the Latin name means Northern Crown, reflecting its iconic crown-like pattern. So, Greek mythology links this celestial crown to Princess Ariadne. The gods placed her wedding crown in the heavens after her marriage to Dionysus. I'm not to say that. It's one of the 48 classical constellations included by Ptolemy, and Arab astronomers called it Al-Fakam, meaning at the bowl. Be careful how you say that. And a bit more like the position, it's situated between Hercules in the east and Bootes in the west, in the northern celestial hemisphere. Best viewed from mid-northern latitudes during June evenings when it appears directly overhead. So it should be quite well positioned as we speak. So there's a distinctive pattern in a semicircle of with the core stars. It forms a perfect semicircular arc and visible to the naked eyes from dark sites. The jewel Alpha Corona Borealis shines as the brightest central star, representing the crown jewel. The composition of the constellation consists of 7 moderately bright stars arranged in an elegant arc. So there's some details of the brighter stars. As I say, Alpha is magnitude 2.2, which is a blue-white binary. Beta and Nusakan is 3.7, spectroscopic binary. And Sigma Corona Borealis is a yellow double star, and then Zeta is a blue-white double visible in small telescopes. So that's the main stars of the constellation. Deep sky objects. The galaxy cluster Abell 2065 contains over 400 galaxies densely packed approximately 1 billion light years from Earth. The massive structure emits powerful X-rays, making it crucial for dark matter research. Only visible through large professional telescopes due to its extreme distance and faintness. Okay, a couple of variable stars of note. The R Corona Borealis is a yellow supergiant star that unexpectedly dims from magnitude 6 to 15 when carbon dust clouds form in its atmosphere. T Corona Borealis, also known as the Blaze Star, is a recurrent nova that typically remains invisible until dramatic eruptions bring it to magnitude 2. And both stars provide crucial insights into stellar evolution and unusual end-stage processes. Okay, T Corona Borealis itself. There's been a few notes on the internet lately that T Corona Borealis is waiting to go pop. This is an image made by a friend of mine in Kings Winford in the West Midlands, Richard Guests, of the constellation, and with the bottom image he has actually circled Tycho Borealis. It could go nova at any time now. It's a white dwarf star pulling matter off its red giant companion. The star should become a naked eye target when this occurs. So just watch this space, basically. And talking about nova, there's a new nova being detected in the southern sky in the constellation of Lupus.
Hurrah!
Yeah, and at the moment, the Lupus is just below the horizon from our latitude in England, according to Stellarium.
I've still got it. I've still got it.
Yeah. V462 Lupi is also known as Nova Lupi 2025, a bright nova in the constellation of Lupus, discovered by the All-Sky Automated Survey for Supernovae, ASAS-SN, discovered on the 12th of June this year. At the time of the discovery, it had an apparent visual magnitude of 8.7, and it was classified as a classical nova on the 14th of June. You can see there's a little circle just here. Can you see my cursor there? But there's a little
just see it, right? Yeah, just above the middle,
with a location of the nova. Okay, and this is just a shot of the light curve produced this only a few days ago. The actual brightness went from magnitude 8 right up to almost magnitude 5. So it was really quite a big jump.
And I have here an actual photo of the nova.
Okay, if I stop that then now, yeah. All right, got you.
There we are. It hasn't quite reached naked eye brightness yet, and they're not sure whether it's going to.
Right.
But there you are. That's just to prove that it does exist. Nova Lupi 2025.
Yeah.
It's visible with binoculars.
Okay, so we'll stop sharing.
If you can view with it.
Yeah.
Can we stop
because we don't see novae very often, so it's always a bit of a thrill when we do see them, because of course they are laboratories for studying our theories about stellar evolution, particularly that of white dwarfs.
Yeah.
So it's good to see some actual ones in the flesh, as it were. Okay.
I do remember somebody in our society in Wolverhampton a long time ago in the 70s, I think it was, or early 80s, discovering a nova with his back garden.
Really?
Yeah.
Amazing.
Yeah.
Amazing. And who was that? Who was that comet? That Australian comet hunter? What was his name? Can't remember his name. He discovered
George Alcock.
No, it wasn't Alcock. It was somebody else. Might have been. I can't remember. He discovered, I think, 6 or 7 comets, 3 of which he discovered by just looking out of his back door up into the sky and seeing a new comet. I mean, how lucky is that?
Yeah, to discover comets, it's basically done on an industrial basis now. All the big
it is
things. So the only ones the amateur photographer, amateur comet hunters may be able to pick up are the ones very low to the horizon, especially when just before sunrise and sunset. But the main areas are all covered by the big conglomerates. They're always pulling out comets and asteroids and things like that. So that's their domain. But there's still a chance you can always see one.
Absolutely, there's always a chance. Always a chance. Anyway, thank you so much for your further comments about essentially paying a monthly or an annual subscription for the Space Oddities presentations. Obviously, we would make sure that the presentations contain notes so that you can look at them and understand everything that's going on without need of a narration. Otherwise, that wouldn't be fair. So we will make sure that you got high quality stuff, obviously. And so from what everybody said, it looks like a favoured thing could be to have an annual subscription, perhaps at £5 a month. So that would be £60 a year. So yeah. So anyway, we will give that some thought and come back to you next week with some firm proposals and take it from there. So thank you so much for your feedback on that. You know, we were thinking of doing this, but we wanted to find out whether you wanted it and would agree with it. So thank you so much for your feedback on that. That's great news. We can actually now move forward with that. I think that's basically a yes. So Bill Bradfield, could have been Bill Bradfield actually.
Oh yes, could be.
Yeah, could be. I think you may well be right. Thanks, Ian, for that. I forgot his name.
I was thinking of the comet Iris Iraqi or Cacus, whatever.
Iris or Kokoraki. Yeah.
Yeah, Iraqi. Yeah, because they're the Japanese comet hunter as well.
Yeah,
the
Japanese infrared telescope. Yeah.
Yeah, because Messier, he was a comet hunter, wasn't he?
Yeah.
And the king, the French king at the time, Louis, whatever his name, because there's so many of them. He called him. His nickname was Ferreter of Comets.
Was it really?
Yeah.
No, that's interesting. That's interesting.
Bit of history there for you lads.
One thing I was looking forward to when I was away was visiting the Greenwich Planetarium, which I never have since it was built and opened. So we went up to the observatory, and I got the obligatory shot of Chloe with one foot in either hemisphere, which she didn't want to do because there were loads of people watching, and she got very self-conscious about the whole thing, being a teenager. But I made her. No, I didn't. I just said
you chained her down.
No. I was very sweet with her and very supportive. I said, "You do that now, or I kill you." So, and she did.
You're going to bribe her. Sweet. With Skittles from the airport, yeah. Those expensive Skittles.
Yeah, we went into WH Smith at Heathrow, and she said, "Can I buy a bag of Skittles?" That's the sweets, not the wooden things you bowl at. And I said, "Yes, you can have a bag of Skittles." And when we went to pay at the self-service, it was £9.80 for a large bag of Skittles. Just unbelievable. Unbelievable. Anyway, so we went up to Greenwich and we asked them when the planetarium shows were, and they said, "Oh no, you can't see that. The last show is at 3:30 in the afternoon." And we missed it. I mean, what planetarium does its last show at 3:30 in the afternoon, for God's sake? So just be warned, viewers, if you go into the Greenwich Planetarium, they finish really early. So I'm absolutely gutted now because that's another occasion that I didn't get to visit it.
So did you walk up the hill?
Oh, we did walk up the hill, but it was a hot walk, put it like that.
Yeah, I bet.
But it was lovely. Paul, nice to see you.
Ian says Terry Lovejoy.
Lovejoy.
He's an antique dealer, isn't he, Lovejoy?
There was Comet Lovejoy, wasn't there?
Yeah, that's right.
There was.
Yeah.
Our homework is to find out who we're on about.
I think it was Bill Bradfield. Anyway, I think that just about brings us to the end of this evening, unless anybody's got anything else they want to say. We'll be back next week, of course.
Just remind the people that there is a launch tomorrow morning from the AX4 mission to the ISS at 7:31 UK time. If anyone wants to catch that on.
Yes, the Axiom 4 private space mission.
Yeah,
and it's the fourth.
I don't think we can cover it here, but that's going on tomorrow morning.
Yeah, absolutely.
Yeah, that came out of the blue, didn't it?
Don't forget, if you would like to buy us a coffee, you can do so by scanning the code or clicking the link in the chat to keep our caffeine supply up through these summer days. So thank you very much indeed. And also don't forget your merchandise, Astronomers' Lives Matter, and get your lovely merchandise here. So that's the link, or you can put the link in the chat. Yes, being pointed out by my gorgeous pouting assistant Roger there. So there we are. So that's where you can buy your Space Oddities t-shirts and hoodies, and thank you very much for that. As ever, don't forget to like, comment, and subscribe, please. It really, really helps the channel, especially the comments in the comment section after the live stream. I have Sandra. Well, next time.
And she's upset she missed the coffee.
Oh, I'm sure she is.
I've told her the coffee troll has just arrived with biscuits.
Yeah. We'd love to show you the back of it. And it's the same with Daz. We'd like to see the back of him as well. So there we are. Okay. All right then, guys.
It's only borrowed.
Yeah. Borrowed, of course. So thank you so much for being here. Thank you for your feedback about the subscription for the presentations. Much appreciated. Thank you for being here. And we'd be nothing without you. So we'll be back next week, and Lou will be returning to be with us next week. I'm not quite sure what we're up to next week, but keep your eyes posted on the channel. Don't forget to visit the website, and don't forget, if you want to send your images to the gallery, send them to gallery@spaceoddities.space. 1 image per email, please, and that will make Roger a very, very happy man. All right then. Thanks to you, Paul, for being here, and we're glad that you've enjoyed yourselves. And stay safe, everybody. Have a fantastic week. Look after each other, and we'll see you next week. So from